Welcome back to the loft. My name is Paul. I'm a musician, an educator, and I love to build things. I also love all things aviation, and in this series I am building a 737 fully motorized throttle quadrant to use with my favorite flight sim, X-Plane. The print files for this project can be purchased at 737DIYsim.com. I hope that these videos will inspire some of you to start your own similar project. If I can do it with little to no electronics and programming experience in a very small build space, you certainly can too. Before we get started on part 3 of the build, I want to take a quick step back and have a look at the bigger picture of the build. First, let's look at the housing parts. There are 3 main sections: the left, the center, and the right. In episode 2, I was working primarily with the left side case. This case houses the speed brake and the number 1 throttle lever. The right-hand side case houses the flaps lever and the number 2 throttle lever. And the center acts as the bridge that connects the left and the right cases together. So getting back to the build, we're going to go back to finish what we started in episode 1, and that is the throttle arm. Okay, let's get to it. My task here is to replace these 2 orange PLA templates with aluminum parts. The aluminum will make the throttle levers much stronger and stiffer. You can see here that I rounded the edges by filing them down. I marked the screw hole locations and drill the holes. Then I tapped them for the screw threads and then finally countersunk the holes. So let's pause the build here to talk about how the simulator actually knows what power level the throttles are set to. In this build, I'm actually using 2 different types of sensors: a traditional potentiometer and a Hall effect angle sensor. As shown in video 1 of the project, the build plan calls for a 10K potentiometer to be installed in the throttle stem. The spur gears turn the shaft on the potentiometer, and inside there's a physical contact that slides along a resistive track as the lever moves. That changes the voltage and sends a signal to the computer through the Arduino, which tells the simulator the reverse throttle position. It's simple, compact, and should work really well, and I suspect it was chosen for the reverse thrusters because it's much smaller than the Hall sensor and actually fits in the casing quite nicely. To be clear, I'm a complete beginner, and 3 months ago I didn't even know what a Hall sensor was. The Hall sensor works differently, and instead of touching anything, it uses a small rotating magnet attached to the throttle shaft. As the magnet turns, the sensor reads the changing magnetic field and converts that into a voltage signal, again from 0 to 5 volts. So, both sensors are doing the same job, essentially telling the simulator where the throttles are, but in very different ways. 2 different approaches, same goal, but together they help make this feel a lot closer to the real thing. Now it's time to get into some electronics and test the position of one of the Hall sensors by hooking it up to an Arduino Leonardo. After a few unsuccessful attempts, I learned that the USB-C cable that I used wasn't rated for transmitting data. It was for power only, and once I found the proper cable, everything came together. With a little help from my good friend Claude, I made the connections correctly and managed to get the numbers moving on the screen. I must say, I felt quite exhilarated when this finally worked. Okay, we are back to building, and we are currently at step 83, where we assemble the fuel lever for the number 1 engine. This step involves inserting 2 688 bearings into each side of the printed assembly. Step 85 is to insert an M4 socket head screw through an 8mm expansion spring, and then attach the screw to the assembly. Alright, now we are back to the metal shop, or more specifically the wooden TV dinner tray, to mill the lever for the number 1 fuel cutoff assembly. Okay, I can hear what you're thinking, and yes, I need to buy a saw. And step 86, attach the start handle with a couple of M3 countersunk screws. Step 87 is to insert an M4 5mm socket head screw into the start lever. Then we will insert the start lever into the assembly. And next we'll secure the lever into the stem with an M4 socket head screw through the other end of the compression spring. Step 91 is the final step for the number 1 start lever, and that is to place another 8mm spring onto the screw threads on the other side of the unit. Some of these steps just speak for themselves. Thanks for joining me in this build project. As a small favor to me, I would really appreciate a like and subscribe. It's free and it helps motivate folks like me to keep making and improving these videos, and share more projects like this one. A reminder that all of the print files are available for purchase from 737DIYSim.com. Step-by-step instructions as well as wiring diagrams and parts lists are available on that site as well. The designer is based in the UK, and so if you are in Canada or the US, I have sourced all of the parts through either Amazon or AliExpress, and all of the links for the parts as well as the tools I'm using are linked in the information section below. So be creative and make stuff. See you next time.